Hello everyone, welcome to Inspire Mathematics. Today we will solve a problem from abstract algebra. This is a problem from group theory and this problem is asked in GATE 2024 and this problem is also very important for PhD interviews. Like this question is asked in NBHM PhD interview 2024 and this is also asked in IIT Madras PhD interview 2024, and in the next sessions of PhD interview in various institute this problem may be asked. If someone gives interview in abstract algebra, then they may face this question. So let's solve this problem. The problem is, let G be a group having exactly 3 conjugacy classes, then identify G. So let's solve this problem. We divide this problem in we divide this solution in two parts. First, consider the case when G is abelian. Let G is abelian. Let G is abelian. Then if A belongs to G, then class of A is what? Class of A is collection of all equivalence, collection of all elements of G which is conjugate to A. Okay, now since G is abelian, these two commutes and this becomes singleton. So if A is in G, then class of A is singleton. So what is the class equation of A? Class equation of G. The class equation of G is nothing but 1 plus 1 plus 1, because if we take any element from G, then it class contains only one element. This is the class equation of G. Okay, class equation of G. Okay, then order of G is equal to 3. Now G is an abelian group and order of G is 3. This implies G is nothing but Z3. G is isomorphic to Z3. Okay, if G is abelian and G has exactly 3 conjugacy classes, then G is isomorphic to Z3. Now we consider the case when G is non-abelian. Let G be non-abelian. This is not is, okay, this is let G be. Okay, let G be non-abelian. Then we first we have to identify the order of ZG, because in class equation there is very important role in order of ZG, because if an element of G comes from ZG, then it commutes with every element of G. So class of that element is singleton. So here if order of ZG is 3, if order of ZG is equal to 3, then what is the class equation? Then class equation is order of G is equal to 1 plus 1 plus 1. Since there are only 3 conjugacy classes, then this is all equal, this is 3. Now order of G is 3 and we know that every group of order 3 is abelian. This implies G is abelian, which is a contradiction, which is not the case. Therefore order of ZG is less than or equal to 2, and order of ZG cannot greater than 3, because if order of ZG is 4, then there are 4 conjugacy classes. If order of ZG is 5, then there are 5 conjugacy classes, but here we have only 3 conjugacy classes, so order of ZG cannot be greater than 3. Now there are only 2 cases. This implies order of ZG is 1 or 2. Now if order of ZG is equal to 2, then what is the class equation? Then the class equation of ZG, then the class equation of G is nothing but order of ZG is 2. So here 1 plus 1 and A is equal to class of some element A where A does not belongs to ZG. Okay, here we have only 3 conjugacy classes, so we write 3 conjugacy classes. Okay, 1 plus 1 plus A. Okay, so this is equal to 2 plus A. Now we know that this order of class of A is nothing but the index of G, index of CA. CA is centralizer of A. CA is centralizer of A. This implies, since this is a finite group, this implies order of class of A is equal to order of G, since the groups are finite, and this we can write this order because this CA is a group, C is a subgroup. This implies order of G is equal to the number of elements is in class of A into order of CA. So what we get, and this is easy, you know this, class of A divides order of G. This is divide sign. Okay, class of A divides order of G. Now what we get? Well, we get class of A divides order of G. And what is class of A? Class of A is equal to A, and order of G is equal to 2 plus A. This implies A divides 2 plus A. Now this A divides A. This implies this A also divides 2. This implies this A is equal to 1 or 2. If A is equal to 1, then we get same order of G is equal. What is order of G? Order of G is 1 plus 1 plus 1 plus 1 plus A. Order of G is 1 plus 1 plus, and the value of A is also 1. 1 plus 1 plus 1. And every group of order 4 or order 3 is abelian. So we get a contradiction. Okay, so this is not true. So if A is equal to 1, we get a contradiction. If A is equal to 2, then again order of G is equal to 1 plus 1 plus 2, and every group of order 4 is also abelian. So it is not it cannot happen. So it cannot happen, since every group of order 4 is also abelian. So order of ZG cannot be 2 also. Hence order of ZG is equal to 1. Then if we write the class equation, this class equation is 1 plus A plus B, where A is equal to number of elements in class of A and B is equal to number of elements in class of B, where A and B are elements which belongs to G minus ZG. Okay. Okay. Here we denote A. Here we have some notational problem. We give this A prime. Okay. Okay. This here we. Okay. B prime. Okay. A prime comma B prime. And okay. Now this is the class equation now. Now if this A equal to B, sorry, this A equal to B, then what is the class equation? Class equation is 1 plus A plus A. This is equal to 1 plus 2A. Now again by this discussion, what we give previously, by this A divides order of G, and order of G is 1 plus 2A. Now A divides 2A, this implies A divides 1. Since A divides 1, this implies A is nothing but 1. This implies B is equal to A is equal to 1. So here we also get the previous one, 1 plus 1 plus 1. Here we also get order of G is equal to 3. So, and if order of G is 3, then the group is abelian, which is not true. So a contradiction, because in this case we assume the group G is non-abelian. Okay. So A is not equals to B. We assume A is less than B without loss of generality. Loss of generality, we assume A less than B. Okay. Now since A is less than B, this implies A plus 1 is less than or equal to B. We use this. Okay. Now here in this case, class equation is order of G is equal to 1 plus A plus B, and B divides order of G by this that previous discussion. B divides 1 plus A plus B. Now this B divides B, this implies B divides A plus 1. Okay. This implies B is less than or equal to A plus 1. Here we get B, A plus 1 is less than or equal to B. Here we get B is less than or equal to A plus 1. Combining, we get B is equal to A plus 1. Okay. So we get B is equal to A plus 1. Also, this A divides order of G, and order of G is 1 plus A plus B. This implies A divides 1 plus B. Now this B is equal to 1 plus A again. So this calculation is quite laborious, but this is easy. 1 plus A, this is equal to 2 plus A. This implies A. Now A divides, now this A divides A, this implies, and A divides 2 plus A, this implies A divides 2. Therefore A is equal to 1 or 2. Now if A is equal to 1, then b is equal to a plus 1, which is equal to 1 plus 1 is equal to 2. So what is the class equation? Class equation is 1 plus a is 1 plus b is 2. This implies order of G is 4, a contradiction. This is also a contradiction, because every group of order 4 is abelian, and in this case we assume the group is non-abelian. So a cannot be 1. So a cannot be 1. This implies finally a is equal to 2. Okay, finally we get a is equal to 2. If a is equal to 2, then b is equal to 1 plus a. 1 plus 2 is equal to 3. So finally we get the order of G is equal to 1 plus 2 plus 3, and this is class equation of S3. This is the class equation of S3. Equation of S3, and S3 is also non-abelian, and S3 is non-abelian. Okay. The S3 is non-abelian. So finally, in second case, where we assume order of G is, G is non-abelian, we get the group S3 only. So G is isomorphic to S3. So if we summarize the result, we get, if G is abelian, then G is isomorphic to Z3, and if G is non-abelian, then G is isomorphic to S3. And in GATE, the question is given there are how many such groups, which has exactly 3 conjugacy classes, and the answer is 2. So the number of such group is 2, and in GATE this is given in NAT type question. Okay, this is very nice problem. The question is easy, but the calculation is quite confusing. The calculation is confusing, but the idea is very simple in every case. The idea is same. In fact, the idea is same in every case. So if we like this video, please subscribe my YouTube channel and like this video. Thanks for watching.